Now, dear students, I welcome you for the first lecture of heat transfer operation. The heat transfer operation, first we will understand the basic purpose of this subject. Now, we are trying to understand the heat transfer operation for the purpose of designing the different heat exchange equipments used in the process industries. Now, what are the basic different equipments that is used in chemical process industries? Generally, it is your heat exchangers. Now, there can be the different types of heat exchangers that can be used depending on its purpose. The name can be different. So it can be the simple shell and tube heat exchanger, plate type heat exchanger. Then there can be the condensers, evaporators, boilers, reboilers. Then there can be certain radiation equipments also. So the basic purpose of understanding this subject is to able to design the different equipments used in chemical process industries, and the performance of those equipments should fulfill the given requirements in the industry, so that your designing should be correct and should fulfill all the requirements required in the process industries. That is the basic outcome for this course. Now, the 3 lectures and 1 tutorial. However, we don't take tutorials, so we will be conducting 4 lectures a week. Then the total university marks is 80, college sessional marks is 20 marks. First, we will try to understand the syllabus. Now, the concepts of the heat transfer that is there. The introduction and mechanism for the heat transfer. What is basically the heat transfer? Heat exchange, heat transfer, the two different terms are there. The development and use of general differential equation for heat transfer. So this is the basic important equation that is required to be developed and used for the general differential equation for the heat transfer. That will incorporate the diffusion term, the generation term, the unsteady state terms. And this general equation, with the application of certain conditions, it can be reduced to Laplace equation, Fourier equation, Poisson's equation, and first we will try to develop this general equation in the Cartesian coordinate system, then the cylindrical coordinate system, and then the spherical coordinate system. That means we are going to develop this general differential differential equation for heat transfer, which is considered to be the basic equation for understanding the heat transfer. And this equation has to be modified to give the different conditions, different situations, and the same equation that will be useful for different purposes. So this general differential equation is very much needed and important to understand the basic heat transfer concepts. Then consider any thick slab. You can consider a thick slab, a metal slab, or a book also. If I am going to supply the heat on one side, then what will be the temperature on the another side, or how the temperature distribution that will be there throughout this metal or a book. So at this point what will be the temperature, at this point what will be the temperature, at this point what will be the temperature. So I should be able to calculate the temperature distribution in this slab. If now it's a say 100 degrees Celsius, this is the outside temperature, what will be the corresponding the other side temperature? So at this end it will be 100 degrees Celsius and it will drastically reduce, say for example, to the 50 degrees Celsius on this side. A certain temperature that is maintained on the another side of the slab. So the heat from this side will be transferring to this surface and then to its surrounding. So we have to understand the different situations to calculate the temperature distribution for steady state conduction for various shapes and geometries. This is what we have talked related to the slab. Similarly, we are going to discuss related to the cylinder and the sphere also. That means it's a cylinder. I am going to supply the heat on one side or from the inner surface also, and what will be the temperature distribution. Similarly for the sphere also. So basically three geometries we are going to consider: the slab, the cylinder and the sphere. They can be solid or they can be hollow also, with the various boundary conditions. That means the boundary conditions, what will be the temperature inside, outside temperature if I am going to supply the heat to the surrounding. Now presently say it's a 30 degrees Celsius the surrounding temperature, and what will be the inside water temperature at the center, that I can calculate by using the different conditions. So boundary condition, that means on the surface, outer surface, what is the temperature? At the center, what will be the temperature? That is what? At a distance x. That means distance x means nothing but your radius. What will be the temperature gradient that will be there? So I have to calculate the various temperatures distribution inside the different simple geometries, and that can be with heat generation and without heat generation. So a heat generation, a source has to be considered, because all these different things, they are incorporated in your general differential heat transfer equation. This incorporates the different terms, that is the diffusion term, the generation term, the unsteady state term. So basically three terms we are going to consider: the diffusion term, generation term and the unsteady state term. And based on this, we are going to discuss these three situations. Based on the generation term, we are having with and without heat generation. For unsteady state, that is variation with respect to the time. Unsteady state, that is the variation of a temperature with respect to time. That means I have put a certain hot metal ball in the surrounding. Say its initial temperature is 100 degrees Celsius, and after that it is kept in a surrounding of say 30 degrees Celsius. This water is at 100 degrees Celsius. This is kept in a surrounding of 30 degrees Celsius. Now, how the temperature of this bottle is going to vary with respect to time? After a certain time, the water will attain the same temperature as that of the surrounding, that is 30 degrees Celsius. But how much time I am going to require to reduce the water temperature, inside water temperature to 30 degrees Celsius? Will it require 1 hour? Will it require 2 hours? Or will it require the 3 hours? That is what the unsteady state problems are to be discussed or considered. The variation of temperature, variation of inside water temperature with respect to the time. Because I have kept the water initially at 100 degrees Celsius, it is going to reduce the temperature, or it is going to lose its temperature slowly. Initially the rate may be the higher, and then it will gradually reduce. The rate will gradually reduce because of the temperature gradient, the temperature difference. This temperature difference is the root cause of heat transfer. Why heat transfer takes place is only because of the temperature difference. This is the basic requirement of understanding the heat transfer. Why heat transfer takes place is only because of the temperature difference. Similarly, why the mass transfer takes place, that is only because of the concentration difference. So difference in the concentration, temperature, or the flow or the energy, any energy, when it will flow, whenever there is a difference, gradient, that is going to cause to flow the from higher level to the lower level, whether it's a temperature, whether it's a energy, whether it's a material, whether it's a fluid. You have already studied the fluid mechanics or fluid flow operations. So why that is going to take is because of the momentum difference. So momentum difference, temperature difference, concentration difference, that is going to lead to the different subjects. So this heat transfer, that is related to the temperature difference, and which is the root cause for understanding this subject. This subject of heat transfer is not only studied by the chemical engineers only, but this is also studied by the mechanical engineers in depth. But the purpose of there is for the maintenance. So what are the different maintenance activities that are needed, how it is to be fabricated, is basic purpose of a mechanical engineer. And for a chemical engineer, how it is to be designed and how it is to be operated. That is a difference for understanding by the mechanical engineer and by the chemical engineer. Chemical engineer has to operate the heat exchanger or the heat transfer equipments. However, the mechanical engineers they understand from the point of view of its maintenance, if they are in the maintenance department. Also, the fabrication is the purpose of a mechanical engineer. So what is this purpose, and with what respect I have to study this subject? That also varies from branch of engineering. For the designing purpose, that is the basic purpose, higher level outcome of this subject is that you should be able to design the heat transfer equipments used in the chemical industries for which will give you the suitable performance. Then this heat transfer, that is the mechanism of heat transfer, the way by which the heat transfer that is taking place is by the conduction, convection and radiation. The three different modes of heat transfer, you can say, three different mechanisms: conduction, convection and radiation, the details of which we are going to understand afterwards. The unsteady state heat transfer, the second unit, unsteady state heat transfer, fins and insulation. So when you talk a unsteady state heat transfer, that is what? A variation with respect to temperature, with respect to time. Variation of temperature with respect to time. dt upon dt, variation of temperature. T, that is the capital T, and the temperature. dt upon small t. This T is temperature, and this T is time. So that is what you have to remember, the temperature and the time. Variation of temperature with respect to time, that is related to the unsteady state condition. So what is the variation of temperature with respect to time? This is most important thing that is also to be studied. For that purpose, we are going to understand the lump capacitance model. For that, the Hessler chart and the error function that will be studied. Then the second topic related to this, that is the fins. The classification of fins, fin efficiency and the overall effectiveness. Now all of you have seen the fins to your bike engine, which is open. You can see this bike engine. There you can see the fins. So there are the small plates which are available for that engine. That is for the purpose of heat loss, heat transmission. The engine temperature should not be higher. So you are making a more surface area by providing the fins so that more heat that will be lost. This is the basic purpose of the fins, extended surfaces. So we are increasing the surface area. Heat, basically engine is of this size, is having a certain surface area, but when I am going to provide the fins, I have attached this fin attach this fin, I can put the different fins so that my heat transfer area that is going to increase. And this increased heat transfer area which is going to reduce the temperature of that engine. So similarly, in case of your furnaces, direct radiation zone and the convection zones are there. In a furnace, convection zone, the tubes they are studded. So that is the purpose of providing the studs or providing the fins, so that you are extending the surfaces so that the heat transfer will be at a faster rate. The next is the insulation. Insulation is to prevent the heat losses. That is to optimize or reduce the cost of heat. In case of your refrigerator, you are putting the insulation to the complete walls of a refrigerator. That is a polyurethane insulation that is used. That is for the cooling purpose. Besides that, the thermocol that is also used for the cooling purpose. So these different types of insulations, they are used to prevent the heat losses. Then what should be the critical insulation thickness? The concept of critical and economical thickness of insulation and its evaluation for cylindrical and spherical heat transfer equipments, that we are also going to study. Next unit is the natural and forced convection, that is heat transfer without phase change. Convection is there but without phase change. However, in case of a condensation and boiling, there the convection heat transfer with a phase change that is taking place. That is without phase change and this is with phase change. Both are related to the convection. So we are having the two units related to the conduction, first two units. Then the convection, third and fourth unit. That is the heat transfer without phase change and heat transfer with phase change. So when we are talking the natural and the forced convection, you require to correlate it with the laminar and turbulent flow over the flat plate, over the cylinder and over the sphere and through the channels. How the fluid that is going to pass through a pipe or over a certain plate. If this is the plate, how the fluid that is going to pass, what will be its velocity, what will be its temperature gradient, यहाँ पे temperature wall surface पे temperature क्या आएगा, then at this point what will be the temperature, at this point what will be the temperature. So I am going to calculate the temperature gradient over that plate. So the concept and the use of thermal and the hydrodynamic boundary layer and its significance we are going to understand. Besides that, we are going to understand the different dimensionless numbers, that is Nusselt's number, Prandtl number, Grashof number. All these different numbers we are also going to discuss in this topic. Then the prediction of heat transfer coefficient using the theoretical, empirical and analogies concept. So the different equations we are going to study, that is some theoretical equations, basic equations, and those basic equations with certain empirical that is your experimental equations. All researchers, they do research, and from the hundreds of researchers, one combines all these equations, combines all this data, and provide a generalized equation which is accepted by all the people, because that is going to give me the approximately correct values. So these are your empirical or the experimental equations. Not only that, the analogies concept, the correlations, relative, that is also used. So the three different types of equations we are dealing in this, and that is all in terms of the different numbers, like your Nusselt's number, Grashof number, Prandtl number, Stanton number, all these different numbers we are dealing with these equations. Then the next unit that is related to the natural and forced convection, heat transfer without phase change. With phase change, fourth unit. Here, the condensation and boiling, these are the two phenomena that is taking place, where the phase change that is taking place. The condensation, what condensation incorporates? The vapors, they are going to give you the liquid. That is what a condensation is taking place. However, in case of a boiling, you are heating the fluid so that the liquid that is getting converted into the vapors, the phase change that is going to take place. And whenever there is a phase change and incorporating the convection, the different equations that will be required. So these two topics, they're different, with phase change and without phase change. The different types of equations. So mechanism of condensation, there we are going to understand the Nusselt's approach, and that will be applied for the heat transfer in saturated pool and forced convection, boiling of the liquids. Generally, you must have seen the water which is boiling in a transparent beaker or also in a pot in your house. That phenomena one has to understand. Initially, the small bubbles they come, then those bubbles reach up to the upper surface of the liquid, then gradually the bubble size increases, then gradually those bubbles burst and continuous vigorous bubbles forms, and the process of boiling you can observe. So this is what your observation, all this heat transfer that is available in your day-to-day life. You have to observe, you have to understand, you have to analyze the different situations, how the heat transfer that is taking place, what are the different phenomena that is taking place, whether it's a conduction, convection, or radiation heat that is taking place. All these things are to be analyzed, understood, implemented, and then remembered. Then and only then you can master this subject of heat transfer. Then the study of the boiling curve, how the boiling that is going to take place. I already told you, initially as we heat to the burner or put the vessel on the gas stove, small bubbles they come, they disappear in the process of moving upwards, then gradually they reach up to the upper surface. So that is all converted into the boiling curve. The same phenomena which you are going to observe with your naked eyes, that is plotted and shown in graphical manner. So this is what your day-to-day life application understanding is there. Then its significance and relevance in constant wall temperature and constant heat flux boiling with the specific reference to critical heat flux and the minimum heat flux. Then the unit 5, that is of most important concern. the designing of the heat exchangers and the evaporators. For designing the heat exchanger, you require to understand the LMTD concept and the NTU concept. So shell and tube heat exchanger designing by LMTD, that is log mean temperature difference, and the effectiveness or NTU method, number of transfer unit method. So this is the basic purpose of designing the heat exchangers. For that purpose, you require to understand the different fouling resistances. The different resistances which are affecting the overall process of the heat transfer. So understand the different resistances. Any process when you study, we generally calculate the rate determining step, which is the slowest step, right? You already talked this in terms of your kinetics, rate determining step, which is the slowest step. Similarly, here also you have to understand the rate determining step or the which is giving the maximum resistance. Maximum resistance is the understanding, and how to reduce that resistance is the corrective action that you are going to take place. So for that purpose, you are going to overall calculate the overall heat transfer coefficient in the heat exchanger. Then we are going to consider the classification of the heat exchangers. Then designing and the rating of the double pipe heat exchanger, shell and tube heat exchanger, plate type heat exchangers, that we are going to understand. Not only that, the helical coil heat exchangers, spiral heat exchangers, then regenerators, reboilers, that is also we are going to understand. The next is the classification of evaporators. How the evaporators for food industries, concentration of juices that is there, the evaporators they are of very much concern. Similarly, in your pulp and paper industries also the evaporators are of much importance. There we are going to calculate the steam economy, capacity of the multiple effect evaporators, design considerations of the evaporators. So it is all related to the designing of the evaporators and the designing of the shell and tube heat exchangers. So this is the basic purpose of this unit 5, that is the designing. Means initially we are going to understand the basic concepts of conduction and convection, applying those basic concepts of conduction and convection and designing the heat transfer equipments. The next unit is the radiation and the special cases of the heat transfer. The radiation fundamentals, properties of the materials and the heat exchange. Then nowadays use of the solar energy and the thermic fluids. Then the different heat transfer equipments like your furnaces, the agitated vessels, fluidized beds, packed beds, jacketed vessels, immersed helical coils, then spiral coils. All these different equipments are there and which require the different equations also. So the process becomes more and more complicated as you go into the individual operation. So designing of general heat exchanger and then applying it the basic principle for the designing purpose of your furnace, agitated vessel, fluidized beds, packed beds, then jacketed vessels, then immersed helical coil and spiral coil equipments. So all these things that is needed for the understanding of the heat transfer. Generally the books that is used are the B.K. Datta, S.D. Davande. This is what we are generally preferring. Then R.K. Gupta. Then besides that, the Genco Bliss, that is also there. Richardson Colson Volume 1, Volume 2, Volume 6. Now Volume 6, that is of more concern related to the heat exchanger designing. So when we talk related to the heat exchanger designing, that is the Unit 5, this is from the Richardson Colson Volume 6. So not only that, there are the McCabe and Smith, that is also the unit operation of chemical engineering. Then D.S. Kumar, that is also used. Out of this, we are preferring the S.D. Davande, Rajput and the RC6. So this is the general basic introduction for your